So we just discovered that it's possible to describe the solutions of absolute value x plus 2 less than 5 and absolute value x plus 2 greater than 5 using inequalities that don't involve absolute values. So for instance, you can write the solutions of absolute value x plus 2 is less than 5 as x is greater than -3 and x is less than 3. So notice that the word and is used because x must be both greater than -3 and less than 3. So how would we write the solutions of absolute value x plus 2 is greater than 5? So if we go back to our number line here, if you notice we're picking the values here where x is greater than 3 or the values where x is less than -3. So that's how we would write that. We would say x is less than -3 or x is greater than +3. And we use or instead of and because x must be less than -3 or greater than +3, but not both. So similarly, we can describe the solutions. This time we're saying less than or equal to 5 and greater than or equal to 5 as inequalities that don't involve absolute value. So all we'll do is we'll change those values we had before. So for the first equation here, we'd say x is greater than or equal to 3 and x is less than or equal to -3. And then with our second equation, we would say x is less than or equal to -3 or x is greater than or equal to 3. So what do these look like graphically? So it's going to look the same as we did before. This time we're just checking what are the values either below if we're wanting less than the number or above if we want the greater than. So for example here we have absolute value x plus 3 plus 1 is greater than 4. So we're trying to determine where the graph of the absolute value portion of the function lies above the graph of our horizontal line at 4. So if we look here, it lies above 4. If we look over in this section, it lies above 4 when we look over in this section. So that's the values left of x's -6 and to the right of x equals 0. So the solution is x is less than -6 or x is greater than 0. So we can do our own example with this. So again, first thing we always want to look for is that vertex. The vertex is going to be at 2, -3. And we can plot that on our graph. We know we're looking at values. We want less than 1. So the inequality is of the form f of x is less than g of x. So we want to look where our absolute value function lies below the graph. So it lies below the graph of g of x equals 1 between x equals -2. If we use our normal slope, we can find our values here. X equals -2 and x equals +6. So the solution of absolute value x minus 2 minus 3 is less than 1 is x is greater than -2 and x is less than +6.